Okay, the next example is example 16. Two boxes A and B are connected by a lightweight cord and are resting on smooth table. The boxes have masses of 10 kg and 12 kg. A horizontal force Fp of 40 Newton is applied to 10 kg box. Calculate the acceleration of each box and the tension in the cord connecting the box. Okay, so now we have two boxes. So remember, two boxes meaning that two free body diagram, two FBD, because each of these will have their own forces. And then these two boxes are connected by a cord. And then there is an external force pulling the box, okay, to the right. Okay, so now let's identify the forces. Okay, macam biasa, identify the forces. We have weight force going downward, and then normal force going upward. And then since we have the the cord here, you need to apply the tension force. Okay, tension force must be away, okay, away from the box. Okay, and then next one, for this one sama juga. You have weight force and then normal force. Okay, normal force, and then this one also have the tension force. Okay, because it is also connected to this box and also to this box. So maksudnya dua-dua akan ada tension force. Okay, since dia adalah tali yang sama, so tali yang sama, value tension force tu akan sama. That's why bila label tu label yang sama lah, label T. You don't need to label T1 and T2. Sebab nanti kamu akan confuse. You will assume that it has different value. But actually ingat, tali yang sama akan ada value tension yang sama. Okay, and then on box A, we have external force to the right. Okay. So since the force is going to the right, okay, bermaksud acceleration akan follow, which is also going to the right. Okay. Okay, so now lukis FBD going downward, WB. Okay, this one is for MB. Okay, you need to label lah. Biasakan, since we have two boxes, so we have two FBD, so you need to label dekat sini. This one is for mass B. So untuk mass B ke atas is normal force, and then wait, okay, sorry, and then this one is T. So sama juga for this one MA, going to the right is FP, going downward is WA, this one NA, and then to the left it will be T. Okay, and then the acceleration is going to the right. Okay, so each, since they are connected by a cord here, so kalau ada force yang tarik, bermaksud kedua-dua ni akan bergerak. So meaning that this one pun sama, the acceleration is going to the right. Okay, so since they are connected, also the acceleration will be the same. Okay, kedua-duanya acceleration akan sama. So now okay, for this one we don't need to transfer into table. First, because if you look at the question, kita diminta untuk kira acceleration and tension. Okay, kalau kamu tengok dekat sini, acceleration dan tension adalah di X component sahaja. So you don't need to draw a table. But if you want to draw a table, it's okay, boleh juga digalakkan untuk buat table, tetapi sebabkan kita hanya nak cari A and T which is on X component, so tidak perlu buat table pun tidak apa. Okay, so now okay, kita akan tengok this one first. di mana kita ada fx is equal to MBA. So this one, okay, follow the direction of acceleration must be positive. So T dia follow A, so equal to, maksudnya kedua-dua positif lah, MBA. Okay, so tension here will be equal to 12A. So we have first equation, and then next one for MA. Okay, follow direction of acceleration positive, opposite will be negative. So T opposite dengan A, so dia akan jadi negative. Negative T plus FP equal to MA. So masukkan apa yang ada. FP is 40, MA is 10, and then A. So this one boleh susun dia akan jadi 40 minus 10A. So this is the second equation. Okay, so just samakan. Solve macam biasa. Kamu akan dapat 12A is equal to 40 minus 10A. So acceleration is equal to 1.82 meter per second squared. Okay, and the next one we need to find T. So you can use any question. So kita gunakan question yang pertama. T sama dengan 12A. So masukkan. A is 1.82. So you will get the tension is equal to 21.84 Newton. Okay, next one, example 17. 3 wooden blocks connected by a rope of negligible mass are being dragged by a horizontal force in figure below. Okay, suppose that F is equal to 1000 Newton, M1 3 kg, M2 15 kg, and M3 30 kg. Determine the acceleration and the tension of the rope T1 and T2. Okay, so now what we have here, we have 3 blocks, and then these 3 blocks are connected by negligible mass of a rope, and there is a external force. Okay, there's an external force going to the left, and then given the mass of each block is here, and then the external force. Okay, so first of all, macam biasa, always start with identifying the forces on the block, okay, on each block. So we have 3 blocks, meaning that 3 FBD. So macam biasa, going downward is the weight, and since it is on the, yes, of course it is on a surface. Okay, so there will be that one, the normal force. And then we have the tension here. Tension 1. Okay, and for this one pun sama. Weight going downward. Okay, wait, I forgot to label. And then here, N1. And then since there is a tension going to this side, T1. So remember the same, okay, the same tali akan ada the same tension. And then dekat sebelah sini pula, tali yang berbeza sudah. So we label as T2. And then here pun sama. And then tension as well, T2. Okay. So now what we want is, we want to draw the FBD. So this one is M1. So M1 going to the right is T1. Upward is N1, and downward is W1. And then M2, we have going downward W2, upward, and N2. Okay, so we silap di sini. N2, this one N3. Then going to the left, T1. Going to the right, is T2. And then for M3 here, this one is T2. Going downward is W3. And then upward will be N3. Okay, wait, I forgot here. There is external force F. Okay, so now we want to determine the direction of the acceleration. Okay, so since the external force is going to the left, so acceleration pun akan going to the left. Okay, so acceleration going to the left. All of this. Okay, so now we want to find the value for acceleration. Okay, so since we know that according to Newton's second law, we know that the sum of force is equal to the sum of MA. Okay, as you can see on the diagram, okay, we have the force here. Okay, the force here that is pulling all of the 3 blocks together. So meaning that this is the net force sebab dia adalah force yang sama yang tarik ketiga-tiga blok ni. So the net force here will be equal to the sum of the mass here times with the acceleration. So meaning that here, so the net force is 1000. The sum of the mass maksudnya akan sama dengan M1 plus M2 plus M3 times with A. So since A dia adalah sama, okay, semua ni akan ada acceleration yang sama sebab they are connected with the rod here. So basically dia adalah macam ni sebenarnya. Dia akan jadi M1A plus M2A2 plus M2A3. Sorry, M3A3. But since A1 sama dengan A2 sama dengan A3, which is also equal to A, we can leave it like this. So just masukkan M1 3, M2 15, M3 30. Okay, so kita akan dapat value acceleration which is equal to 20.83 meter per second square. Okay, so kamu tidak perlu buat untuk satu-satu dekat sini sebab basically dia adalah benda yang sama. So terus keluarkan this formula here. Okay, this formula here, so kita boleh tambah saja the mass. Okay, so next one we need to find the tension T1 and T2. Okay, for this one we need to refer to the FBD. Okay, again you don't need to draw a table since kita hanya gunakan X component sahaja. Okay, so now we want to find T1 and T2. Okay, so first kita tengok this one here. Okay, T1 dekat sini, okay, adalah opposite direction dengan A, so dia akan jadi negatif. M1A, okay. T1 akan jadi negatif sebab dia opposite direction dengan acceleration, so F akan jadi positif. Tambah F sama dengan M1A. Okay, and then masukkan negatif T1, F tadi adalah 1000, sama dengan M1 is equal to 3. A pula kita sudah dapat. So kita akan dapat T1 is equal to 937.51 Newton. So T2 kita boleh gunakan the second one. Okay, the sum of Fx is equal to M2A, di mana T1 follow the direction of A, so T1 akan jadi positif, T2 pula akan jadi negatif. So T1 minus T2 is equal to M2A. So T1 kita sudah ada. minus T2, okay, equal to M2 is equal to 15, and then A 20.83. So you will get T2 is equal to 6 to 5.06 Newton.